Okay, question number 4. A mass at the end of the spring oscillates with a period of 2.8 seconds. The maximum displacement of the mass from its equilibrium position is 16 cm. So, question A. What is the amplitude of the oscillations? B. Calculate the angular frequency of the oscillation. C. Determine the maximum accelerations of the mass. And D. Determine the speed of the mass. So, I call out my pen first. Okay. A. What is the amplitude of this system? Okay, so it say that the maximum displacement here. Okay, the maximum displacement. Pay attention. Maximum displacement here means amplitude. Okay, this means amplitude. Okay, so I will know that my amplitude here is actually 16 cm. Okay, now B. What is calculate the angular frequency of the oscillations? Okay, now giving you that the period is at 2.8 seconds. So I know that my angular velocity will be 2 pi f and is 2 pi t. So replace the period inside, I supposed to get 2.24 radian over second. Okay, radian over second. Now part C. Determine the maximum accelerations of the mass. Determine the maximum acceleration of the mass. So I want to find my maximum accelerations. Okay, so now recall your accelerations. Accelerations is A equal to negative omega square x. Okay, for an oscillations. So if I want to find A max, it means that my x must be max. Okay, so my displacement must be a maximum displacement. So negative omega square, so the omega will be the same all the time, so it's which just we calculated in part B. I just call it back here, and now your x max actually is your amplitude. So your amplitude just now we calculated is 16 cm, so now I have to convert back into meter. Okay, so I supposed to get back negative 0.803 meter over second square. Okay, now part D. Determine the maximum speed of the mass. So according to the oscillation equation, V will be equal to x omega. So if I want to find a V max here, so my x again is a maximum. So it's supposed to be our omega, which we have calculated in C. Also, it's supposed to be our amplitude, which have been calculated in C. So again, replace the amplitude x 0.16 times back the omega is 2.24. So you will get at 0.36 meter over second.